a to the b equal to c, and c to the a equal to a. We want to find a, b, and c, or the relationship between them. So in the first step, we try to use replace. I say a equal to c to the a. If I replace it here, c to a, the b equal to c. By power rule, I can say x to the m to the n equal to x to the m n. So here, I can say c, the ab equal to c. Now, this part, because on both sides I have c, I try to do what? I try to divide both sides by c. If I want to divide both sides by c, maybe c is 0, and you can't divide by 0. So I should check two cases, or consider two cases. Case 1, c is 0. Suppose it is first equation, and it is second equation. So if I use in first and second equation, and I replace c with 0, and I have a to the b equal to 0, and 0 to the a equal to a. From this part, the only possible case to reach 0 is a0. If I replace here, the left-hand side will be 0 to the 0, which is undefined. And because it is undefined, so here we don't have any answer. Now, let's consider case 2. In case 2, c is not 0. We call this equation number 3. So in equation number 3, I divide both sides by c. So I know that if I have x to the m over x to the n, it will be x to the m minus n. So when I divide c to the ab over c equal to c over c, left hand side by power rule will be c to the power of ab minus 1. Right hand side is 1. So we have this. So I should solve the equation that I have something to the power of something equal to 1. If I want to analyze this, suppose x to the y equal to 1. I want to consider different cases. The first case is x equal to 1. Second case, x equal to negative 1, but y should be even. So y equal to 2z, which z is integer. Third one, y equal to 0, the power is 0, and the base shouldn't be 0. So when something to the power of something is 1, we should analyze these three cases. Now I want to analyze here. 1, base is 1, x is 1. So here, say c is 1. So if I replace in these two equations, in first equation, c is 1, also in second equation. In first equation, I say a to the b is 1. In second equation, c is 1. 1 to the a equal to a. We know 1 to the power of any number is 1. So from here, a is 1. And here, we can conclude 1 to the power of b should be 1. So b can be any number. So in this case, if we analyze, c is 1, a is 1, b can be any number. 1, b, 1. Okay, we've considered case 1 and we've reached 1b1. Now, let's consider second case. If we consider second case, we can say, oh, here, x is negative 1, base negative 1. Here, c is negative 1. I write c equal to negative 1. Okay, c is negative 1, and also we can say y equal to 2z. The power is should be an even number. Here the power is what? AB minus 1. So AB minus 1 also should be QZ, which Z is an integer. Now, let's replace in our first and second equation. We know a to the power of b equal to c to the power of a equal to ca. If I replace c negative 1, a to the power of b is negative 1, negative 1. The power of a equal to a. From here, a should be negative number. Also, b should be odd number. B is an odd integer. Unlike the previous case, here no. B is an odd number. Now, minus 1 to the power of a equal to a. So from this part, we conclude a is an odd number. Why? Because we know a is negative. Here it is negative. When it is negative, a should be an odd integer. A is an odd integer. So a, for example, equal to 2k plus 1 and also negative 2k plus 1. Which 2k plus 1 is positive integer, or I can write it like this. Positive integer. So if I replace negative 1 to the power of negative 2k plus 1 equal to negative 2k plus 1. So negative 1 to the power of negative this number, you can say the left hand side is negative 1, the right hand side is negative 2k plus 1. So we conclude that 2k plus 1, if multiply both sides by negative 1, is 1. So we conclude a equal to negative 1. Now a negative 1, c negative 1. Let's replace again in our main equation. Let me show you our main equation here. A to the power of b, negative 1 to the power of b, equal to c. C is negative 1. And c, negative 1, the power of a, which is negative 1, equal to negative 1. It works, this one. We should only pay attention to this. We said b is an odd integer. So, yes, if you consider any odd integer, it will be okay. So b should be, for example, 2t plus 1. So here the answer. A negative 1, b is 2t plus 1, which t is an integer, and p is negative 1. Then you can check it satisfies. So we've considered two cases and we've reached two answers. This answer and this answer. So let's focus on third case. The power should be 0 and the base shouldn't be 0. Okay. Y equal to 0, the power should be 0. This one should be 0. AB minus 1 should be 0, and C shouldn't be 0, base. From this part, you conclude AB equal to 1. And if you consider A to the B equal to C, and C to the A equal to A, we have these two equations, number 1 and 2. AB is 1, so you can say B equal to 1 over A, and we know A and B are not 0 because the product is 1. If I replace A to the power of 1 over A equal to C, and C power of A equal to A. If I replace this C here, then A to the power of 1 over A to the power of A equal to A. And we know by power rule that we should multiply A to the power of 1 over A times A equal to a, which we know a to the power of 1 equal to a, it's okay. So a is a, b is 1 over a, and c can be any number, but c is in terms of a. C is a to the power of 1 over a. But we should analyze the domain. Here, because a is in the base, if it is negative, let me tell you. For positive real number, 0 is not possible. A is not 0, the first thing. For a positive, it is okay. But if you have negative numbers here, these should be integer because we should know the sign. So if a is less than 0, if a is less than 0, 1 over a should be integer because it is in the power. And because it is in the power and it should be integer, what can we say? We can say 1 over a, for example, is w, which w is an integer. So a equal to 1 over w, which w is an integer, and w is not 0. So here, if we have one case this, and a can be 1 over w, and because we said here a is negative, so w should be negative integer because it's a is 1 over w, which w is negative integer. So here we've saw and found general form for ABC. We found three types of answers. Let me write the homework. Try to analyze this. That a to the b equal to c. And then b to the c equal to a. C to the a equal to b. And try to find ABC and comment your answers below this video if you want to learn other important ideas. Send message to my WhatsApp number in the comments and also description. Please don't forget to subscribe, turn on the bell, like the video. Thanks. See you next time. Bye bye.